All right, next up, we'll take a look at identifying bases. So bases will either accept H plus or donate hydroxide, right? If they're donating hydroxide, that hydroxide will then accept the H plus. So it's kind of saying the same thing. So the first thing you want to look out for is a hydroxide ion. And so here we have an ionic compound, so it's going to be a metal plus a hydroxide. So for example, sodium hydroxide, that will act as a base because it will dissociate into sodium plus and hydroxide minus. Strontium hydroxide, here we have two hydroxides, and it will indeed donate both of them. Another example, calcium hydroxide. Right, another example of donating a hydroxide. And so all of these are strong bases. Right, this is an ionic bond, so when you dissolve it in water, it will completely dissociate and then thus act as a base. So that one's obviously very obvious. The second thing you want to look for is non-protonated amines. An amine is just basically a nitrogen-containing compound. And the non-protonated means it doesn't necessarily mean that it doesn't have hydrogens on it, but that it has a lone pair, So for example, if we have ammonia, although this indeed does have hydrogens on it, we say it's not protonated because it doesn't have just a proton on it, right? This guy right here can use this lone pair to form a bond with an H plus and then form NH4 plus. And so you can see here it's acting as a base. And so it's important that you have this lone pair free. Right, so there's just a picture of different compounds, nitrogen-containing compounds, showing that they have this lone pair and can act as bases. Remember, this exists is in an equilibrium. So if you add just NH3 to water, it will act as a base. But if you add NH4 to water, it will act as an acid. So just to give you some kind of numbers here, this NH3, CH3, NH2, and then let's see, one more, CH3, CH2, three of these, N, right? You can give these pKa values. This one is 4.75, 3.32, and then 3.28. So they are all weak acids, or weak bases. They are all weak bases. And then finally, the third thing you should look out for is a compound going to be basic is if it's a conjugate base of a weak acid. So look for conjugate base of a weak acid. For example, carbonate is the conjugate base of bicarbonate, and so this can pick up an H plus and thus act as an acid or as a base, This pKb here is 3.7. Same here up here. I wrote pKa, I meant pKb, acting as a base. Nitrite is the conjugate base of nitrous acid, so it can act as a base. HNO2, this pKb is 10.85, so not nearly as strong of a base. And then F minus, the conjugate base of HF, a weak acid, can pick up an H plus and then form HF. This pKb here is equal to 10.9. And again, all of these are weak bases.